Hello and welcome everyone. I see we have a lot of people joining from different parts of the world. So thank you for joining us, and we're excited that you're all here. Today's webinar is about strengthening concrete structures using FRP polymer straps. It is prepared and presented by Dr. Girish Narayan. He is our senior designer and researcher at SFTec Canada. So a little bit about Dr. Girish. Dr. Girish, he received his PhD in civil engineering from the University of Sherbrooke here in Quebec, Canada. And he also did a master's, prior to that, he did a master's of technology in earthquake engineering in India. He got his master's degree from the Indian Institute of Technology in Roorkee, India. He received the University Gold Medal in 2013 for the Bachelor of Technology project on strengthening of reinforced concrete columns with externally bonded fiber reinforced polymers. And that was from the Veer Surendra Sai University of Technology in Burla, India. His research basically included, he had a lot of interest in the behavior of structural concrete reinforced with fiber reinforced polymer, testing and characterizations of FRP material, and nonlinear finite element analysis of reinforced concrete structures. Dr. Girish, as I mentioned, he is now a senior designer and researcher at SFTec Canada and a MITAX postdoctoral fellow at the University of Sherbrooke. Dr. Girish, the mic is yours.
Thank you, Rick, for the brief introduction. The major problem faced by civil engineers worldwide is the premature deterioration of concrete structure, and which generally affect the economic of a nation. And therefore, the structure required strengthening. And one of the strengthening technique is to use externally bonded fiber reinforced polymer. So, which is the talk of the present session, strengthening of concrete structure using fiber reinforced polymer straps. So through this presentation, I will give a brief overview of application of carbon fiber sheets in civil infrastructure, construction process, and a case study on strengthening of bridge structure using carbon fiber laminate. So before starting my presentation, I would like to introduce our company SFTec. So our products are mostly designed in Canada and are manufactured in China by Sandog Safety Industries, who are specialized in manufacturing of fiber reinforced polymer products. And we work with national and international engineering firms. We work with them through the design process and help them with the fiber reinforced polymer design standards, whether they are in Canada or in the United States. And we generally focused on parking facilities, water treatment plants, and retaining walls. And our main focus is mainly on the glass fiber bar and carbon strap application. We also have other products as AR fiberglasses and connectors, but to the talk of the today's topic is only carbon fiber straps. And the SFT fiber reinforced polymer bars are made from composite materials as shown in this figure. It is made of fiber, and the fiber can be glass fiber or carbon fiber, and it is manufactured by a pultrusion process using a mixture of recycled fibers and resins. And this figure shows a microscopic view of the FRP bar. Three different types of FRP bar, carbon, amarid, and glass, are generally available in the market. And this stress strain plot shows how these FRP bars are compared with the steel bar. 2 points should be noted from this plot. First, the glass fiber reinforced polymer bar have lower strength compared to other two FRP bars, but glass FRP bar have more tensile strength compared to the carbon fiber reinforced polymer bar. And the second, the strength of all these three FRP bars are around 2 to 3 times more than the steel bar. And however, their behavior is linear elastic up to the failure. So we can produce different types of FRP products depending upon the project requirement and client specifications. And some of the FRP bar we produce are straight bars, spiral and stirrups for transverse reinforcement, bent bars, and glass fiber reinforced polymer shear connectors. The glass fiber reinforced polymers bars are widely used due to its production cost, which is very low compared to other types of bar, and have better tensile strength compared to the other fiber reinforced polymer bars. And some of the advantages of the SFTec glass fiber reinforced polymer bars over the conventional steel bars are it have a longer service life because of its corrosion resistance, and therefore it have improved durability in the harsh environments such as construction near the coastal area. And the FRP bar have better resistance against corrosion compared to the steel bar. As I told earlier, the tensile strength of FRP bar 2 to 3 times more than that of the steel bar. However, FRP bars are lighter due to the low density compared to the steel bar. So therefore, the FRP bars are lightweight. And due to the corrosion resistance, FRP bars are good for harsh chemical environments as well. And it is neutral to electrical and magnetic disturbance. Therefore, it have a wider application in airport, military, MRI rooms in hospitals. And some of the selected field application of the SFT fiber reinforced polymer bars we have already done in Canada. And glass fiber reinforced polymer concrete waffle flooring slabs designed with SFT glass fiber reinforced polymer, which was built last year in Halifax, Nova Scotia. And it can also be used for slab on grade. And slab on grade is a type of non-structural slab. And here it is a one-to-one replacement, and it will save a lot of money to compare to the steel bar in terms of labor and transportation. Another project shows the cast on-site precast sandwich panels, and they have used our glass fiber reinforced polymer bars in their projects as reinforcement as shown in this figure. And it was built in China. And in the right side, it is a retaining wall which was built for the city of Montreal. And the retaining wall is designed to dump snow with de-icing salt during the winter. So they built this retaining wall with SFT glass fiber reinforced polymer bar, which provide corrosion resistance against the chemical used in the de-icing salts. Now coming back to our main presentation, the substandard workmanship in reinforced concrete structure due to insufficient compaction of concrete or inadequate cover to the reinforcement causes corrosion of the steel bars, and high level of moisture and excessive fluctuations in heating and cooling can promote the movement of soluble salt, which lead to patches of white crystal as shown in this figure, and can cause considerable damage to the concrete structure. And if the minimum quantity of cement is not provided, it will lead to poor workability and lowering the strength of the concrete. Therefore, it will require external strengthening. The conventional method of repair includes steel jacketing of concrete columns or externally bonded steel plates to concrete beam as shown in this figure. So this strengthening technique using conventional method was found to be effective. However, these techniques are not cost effective and may lead to corrosion after the repair due to the environmental conditions. So now with the advancement of composite material, which was earlier used in the aerospace industries, so now when it came to the civil engineering, so such as like fiber reinforced polymer composite, it found to be beneficial due to its high strength, low weight, and resistance against corrosion. And our product SFT-CarbonStrap have a tensile strength of 3,500 megapascal and with a thickness of 0.167 millimeter. Therefore, the strengthening of concrete structures using carbon fiber fabric have a minimum change in the structural geometry, because the thickness of the SFT carbon strap is around 2 by 10 times of a millimeter. The carbon fiber reinforced polymer sheets can be used to strengthen reinforced concrete elements such as column, and it could improve the flexural and axial capacity of the column, as well as it improved the durability by increasing its service life. As I told earlier, the carbon fibers are corrosion resistant, so it can improve its service life. And the following load displacement plot show the comparison of non-strengthened column with the FRP strengthened column. The envelope curve shows that the comparison indicate that the FRP sheet increased both shear resistance as well as ductility of the reinforced concrete column. As we can see, the strength of the non-strengthened column was around 200 kilonewton, and which was in case of FRP wrapped column, it was more than 300 kilonewton. And as well as the ultimate displacement reached by the column strengthened with FRP was much higher than the non-strengthened column. The carbon fiber reinforced polymer sheets can be also used to strengthen reinforced concrete beams, both in either in the shear or in the flexural. So ideally, these are used for the shear strengthening of RC beams and can be strengthened in shear by providing a full wrap around the beam section or three-sided wrap for a T-beam sections or two-sided wraps. And in case of reinforced concrete wall, which we generally see below the ground, underground, or shear walls in the high-rise buildings or in the bridges, reinforced concrete bridges. So the FRP carbon fiber reinforced polymer can provide both shear and flexural strengthening. And in case of reinforced concrete slab, it is used to provide flexural strengthening by placing either the carbon fiber in one direction or in both directions. Now, safety measures and precautions should be followed while using the fiber reinforced polymer composites, because the material we use here is the glass fiber sometimes. So when the glass fiber is mixed with epoxy, it can become actual glass. So it can be dangerous while working, when you are working with bare hands. So the use of personal protective equipments as shown is essential to avoid eyes and skin irritations. And the various codes and guidelines, which I will give a reference of various codes and guidelines at the end of this presentation. So some codes like ACI 562, which is used to evaluate the performance, the structural performance, or do an inspection or seismic evaluation of a structure. So once the evaluations of the structure is done, so like you can see here, this structure, the cover have completely spelled off and bars are already corroded. So this kind of a structure can be repaired. So the construction process of repairing is followed as by cleaning the surface or removing the surface oil or dust from the surface, then filling the cracks with grouts. And once the surface is free of oil and dust and it has been grouted, then the epoxy adhesive are applied on the clean surface as shown here. The epoxy adhesive are applied using a roller, and then FRP, which was followed by the application of carbon fiber sheet using a roller. The applied carbon fiber sheet is covered with a grout to provide a protective layer or resistance against the fire. Now it is important to know the economic effectiveness of FRP rebars. A study was conducted which compared the economic and technical effectiveness of fiber reinforced polymer and conventional repair for a T-beam section as shown here. This was the T-beam section which was under study, and only 60 feet length was considered for this T-beam, and the T-beam section for repair was this one. And two scenarios were considered which analyzed the future worth of both conventional and surface bounded fiber reinforced polymer technology and it was considered for a design life of 30 years. And in scenario 1, if I am talking about the conventional repair, was designed for a service life of 15 years and should be repaired again after 15 years. So it will repair 2 times. And in case of scenario 2, the conventional repair had a design life of 20 years and will be allowed to degrade after the 20 years, and it will be after the completion of the 30 years, it will be either replaced or repaired. But however, in both the scenario 1 and scenario 2, FRP repair will serve for a conservative design life of 30 years. And I'm saying a conservative here because the FRP repair can have design life up to 50 years. Therefore, fiber reinforced polymer repair have a better design life than the conventional repair. Now, coming to the cost part, a present worth analysis was conducted to compare the initial and life cycle cost for the conventional and fiber reinforced polymer technique. And for the first scenario, which include re-repair after 15 years in the conventional repair, but there was no re-repair in case of the fiber reinforced polymer. So for conventional method, the present worth cost of first scenario was $5,000, which was compared to the $3,400 for FRP repair, which is much higher because in conventional we have to repair the structure 2 times. But in scenario 2, a present worth analysis does not apply because it doesn't include a future repair. So here we can see that the FRP repair improved the design life without increasing the cost of the structure. Now the first case study is of the strengthening of Westgate Bridge of Australia, and the bridge was designed in 1960s and opened for traffic in 1978. So however, the increased traffic load to 7 times the originally designed traffic volume was one of the factors for investigations of the bridge structural health. And the investigation found several areas such as box girder, deck slab or cantilever frame of the bridge had insufficient capacity. So this figure shows where the strengthening was required. So they come up with the following strengthening scheme for the box girder, where the externally bonded carbon fiber in form of 3 layers of unidirectional carbon fiber sheets and 2 layers of carbon fiber laminates were used. So this figure shows the installation of the 2 layers of carbon fiber laminates in underside of the box girder as shown here in this figure. two layers of carbon fiber laminates. So this shows the practical use of those laminates. And to improve the flexural capacity of the deck slab was enhanced by providing carbon fiber laminates in negative moment region above the piers. So above the pier, if you see here, there is a strip of carbon fiber sheets which is provided in the negative moment region, and in the positive region, in the positive moment region in the span direction. If you see all these parallel FRP sheets which are provided in the positive moment region. So coming to another practical example of the application of carbon fiber sheets is the repair of carbon concrete bridge corbel support of the Jacques Loge Bridge, Calgary, and it was in Canada. And as shown in this figure, the concrete corbel supporting the main girder had cracking. As you can see here, there is a cracking here, and this cracking was due to the unexpected friction forces and a lack of sufficient internal diagonal steel reinforcement. So therefore, to overcome this problem, they suggested external strengthening, because we can't provide any internal diagonal steel reinforcement now. Therefore, a strut and tie model was used to design the carbon fiber strengthening scheme. A single horizontal layer and a diagonal layer of carbon fiber sheets were applied on each side of the corbel, and you can see this bridge has been supported here. So this support was removed once the curing of the carbon fiber sheet was completed, and a protective coating was applied over here, and the total duration taken for the repair was around 6 weeks, and it cost around $20,000. Now coming to the conclusion part, due to the low weight to high strength ratio and the minimum change in the structural geometry, the use of fiber reinforced polymer composites in strengthening have advantages over conventional steel plates. The fiber reinforced polymer composites are corrosion resistant, which improves service life of the structure and concurrently reducing the maintenance cost. And the case study demonstrate a successful reparation of the reinforced concrete bridges. Therefore, the carbon fiber has a bright future as a strengthening material, and which is available at SFTec as SFT carbon fibers. You can go through the more details about the SFT carbon strap by going to www.sftec.ca, and these are the list of the North American design codes and guidelines for externally bonded fiber reinforced polymer system for strengthening of concrete structures. So this code ACI 562 is used for generally assessment and repair and rehabilitations, and other codes like 440 is used for the design, and this is for the Canadian Bridge Code, and this for buildings, and the last one is also for materials. This is used for the material testing. So thank you for your giving your time and kind attention. Thank you very much.